Hi, and welcome to Public Cloud Hopscotch, a random selection of things to consider in the public cloud. My name is Robert Schweikert. I'm a distinguished engineer at SUSE. So today we're going to talk about various things. Each of these topics could be talk in its own, so don't expect a deep dive. So we'll start with a disclaimer because there's no better way than to start a presentation that way. We'll talk about how the cloud is more than running things on somebody else's computer. We'll look at bring your own subscription versus on-demand, or also known as pay-as-you-go. We'll look at the SUSE update infrastructure. We'll talk about services, mobility, and data gravity. A few cloud features to consider. We'll talk about LVM. LVM is dead. Long live LVM. And we'll talk about lift and shift or re-architecting. Since we're doing everything digitally this year, please ask your questions in person whenever we meet at some conference, whenever COVID-19 has moved along and we are free to travel again. So let's get right into it with the disclaimer. As I already mentioned, each of the topics I'm talking about could easily be a presentation in and of itself. Unfortunately, SUSECON is digital, so we can't hang out at happy hour and have a beer. As I mentioned, at the next conference, look me up and we'll have a beer together. And I will mention AWS, Microsoft Azure, and Google in random orders. We love all our partners. Nobody's special. We'll work with all of them equally well. And from here, let's look at how the public cloud is more than running on somebody else's computer. So it all started on March 14 in 2006, and AWS S3 was the first public cloud service. Following that year was Amazon AWS EC2, Elastic Compute Cloud, which is the underlayer for infrastructure as a service. Today, of course, all service providers have machine learning, identity management, DevOps tools, container control planes, network as a service, database as a service, security, compliance, Internet of Things, IoT, analytics, and. And of course, there are many public cloud providers. The dominant three are AWS, Microsoft Azure, and Google Compute Platform, GCP. Let's talk about some terms. So cloud native, what does cloud native mean? Cloud native means that you're consuming storage, authentication. Basically, you have an application that consumes all the services or as many services as possible from the framework provider. When you implement cloud native, then you create an affinity to the APIs of that service provider. APIs are not portable. So the AWS APIs and the Azure APIs and the Google APIs, IBM APIs, and so on, they're all different from each other. Depending on how you consume the services and what you're using, you're tying yourself to a certain framework based on the APIs that you're using. If you want to be framework independent, then you end up either using a library such as libcloud that abstracts the framework but doesn't have all the features. So those are choices that you need to make as you're looking at the public cloud. And then you also can, of course, decide on whether you want to run your own database or you want to use it as a service. So that's just one of the examples where there's a decision you can make as to, what you prefer, the service and then tying yourself to that API, or administering your own database and running that inside a VM, basically running it the same way as you do in your data center. So you can treat the public cloud as a co-location that is relatively straightforward, or you can go cloud native. And so here are some of the pros and cons along the way. If you treat it as a co-location, then you're looking at mostly lift and shift. Your known audit and workflows persist, so your audit trail, and so all of that transfers. The learning curve is relatively flat because The only service that you really need to learn from the cloud provider is the infrastructure as a service. You don't have to work with all the other APIs that they have available. And you still run everything. The cons, you remain responsible for HA. So your applications have to be set up in an HA fashion, just the same way it is in the data center. And one of the cons is, well, you still run everything. If you go cloud native, then the pros are that the framework provider is responsible for uptime and scaling. So when you use a service, they have to deliver to whatever they promise, however many nines of uptime of service they promised. You have to have fewer worries about operational efficiency. So if the cloud provider runs a service and they run their service on machines that are too big, that's not your cost, right? You just pay the cost of the service. You no longer run everything. That can be a pro. So that depends on, how you're looking at this, what your viewpoint is. A con is, well, you no longer run everything. You're not in complete control. The learning curve is steeper when you do cloud native as compared to lift and shift. You have to learn all the APIs that say how to set up a database in a cloud native way, how to connect to it, and so on. It requires significant changes in your applications. If they're in-house applications, you have to put in the developer effort. And it provides a framework tie-in due to the API, as I already mentioned. Next topic, bring your own subscription versus on-demand. So bring your own subscription in the cases where you have bring your own subscription, then you bring L1, L2, and L3 support directly from SUSE along with you. That is with your current entitlement. That just transfers and you keep on going on your merry way. There's no upcharge by the CSP, which is the cloud service provider, so you just pay for the basic infrastructure costs. You do not have access to the local update infrastructure that SUSE operates. You are expected to connect to the SUSE Customer Center or use your in-place infrastructure for management of systems. That could be SUSE Manager, SMT, or RMT. So basically, these are treated the same way as on-premise. And the images for BYOS that we make available in the public cloud frameworks, they're available till the end of life cycle of a given distribution. So that means the images are available until the end of LTSS for SUSE Linux Enterprise Server, the end of SPOS, the Extended Service Pack Overlap support for SUSE Linux Enterprise Server SAP, and similar applies for SUSE Manager and other images that we have available there. Then on demand, when you're using on-demand instances, you're getting L1 and L2 level support from the cloud service provider. So you need to have a support contract with AWS, Microsoft, or Google. They will then provide L1 and L2. And then L3 is provided by SUSE through a direct connection with the service provider support teams. On-demand comes with access to the SUSE operated infrastructure. That infrastructure I'll talk about later. And then if you use on-demand, so you want add-ons such as long-term service pack support or live patching, those are only available via SUSE Manager. And there's a blog about this. And also the life cycle is different between BYOS and on-demand. And there's also a blog on the SUSE blogs page along that. The on-demand images are available only until the end of general support. So for SUSE Linux Enterprise Server, that means once the new service pack is released, the images immediately go to the deprecated mode and will then be removed 6 months later. For SUSE Linux Enterprise Server for SAP, the images go into inactive mode. As the life cycle is much longer, the overlap between the two service packs. So here's a quick life cycle overview. Again, there's a blog about this. The life cycle, we have 4 active states, and we also talked about this in the roadmap presentation for public cloud. There's also a demo in that presentation about Pint, which is a tool that helps you find these images, and Pint shows which stage of the life cycle an image is in. So active images are on a 3-month rolling refresh cycle. That means as long as there is no critical security issue, images get refreshed every 3 months. So if we refresh an image on January 1st, then 3 months later, April 1st, the images would get refreshed again, and so on. If there is a critical security update, then we refresh in between, and at that point, the clock resets to 0, and we start counting the 3-month over. Inactive images are images of distributions that are in SPOS period. So that applies primarily to SAP, but it also applies for BYOS images for SUSE Linux Enterprise Server. And they only get refreshed for critical security issues, while active images for on-demand instances, they may get refreshed for bug fixes. Then they're deprecated. Deprecated images basically means the image is going away in 6 months from the deprecation date. And then there are deleted images. Those have been removed from the framework. And you can see here to the left are the state transitions. So when a new service pack gets released, there's a state transition. When the critical security update is released, or regular life cycle refresh. So these are basically the refreshes that trigger the state transitions. So how would you choose between bring your own subscription and pay as you go? So this is really highly workload dependent. So it is important that you understand the nature of your workload. For example, if you have a workload that you don't like to update the OS underneath very often, then bring your own subscription is a good way to go, because it's easy to get LTSS, it's easy to get live patching. While both of those are add-on services that you can get with pay-as-you-go, but then you also need to get a SUSE Manager subscription. So if you have already a contract with SUSE, then BYOS is the way to go for things like that. If you have a bursty workload that is not containerized, maybe a car data collector or something like that, a mix of BYOS and on-demand would work generally really well, where the BYOS instances just run to cover the base load, and then as it gets bursty, you would fire up on-demand instances. A workload that only runs, for example, during business hours, if for example, your accounting is in one country, and all the people that access the account information work in the same time zone, and the application only needs to run, let's say, from 8 to 5, you can set up rules that fires up the instance, let's say at 7:30, and then it stops the instance, let's say, at 6 p.m. And so then, obviously, the instance only runs for those hours, and you can save a good deal of money if you're using pay-as-you-go. Also into play come the support considerations. As I mentioned, BYOS is supported L1, L2, L3 from SUSE directly. For on-demand, L1 and 2 come directly from the cloud service provider, and then the cloud service provider for L3 is backed by SUSE. And again, this is also product dependent, but for SUSE Linux Enterprise Server, SUSE Linux Enterprise Server for SAP applications, this is true. As we bring other applications to the public cloud, such as the Cloud Application Platform and Container as a Service Platform, that will probably change. So next, let's take a look at the SUSE Update infrastructure. So the SUSE Update infrastructure runs region local in all cloud frameworks. So for example, in AWS, there's an update infrastructure in US East 1, US East 2, in South Africa now, and so on. And the same applies for Google and Microsoft Azure. When you start up an instance, the image has built-in knowledge about a so-called region server, and then the instance first calls out to one of the region servers. In every cloud framework, these are running in various regions. We connect to that. We send the region information, the region server information about which region the instance is running in, and then the region server returns information about the update infrastructure. In the second communication path, the instance then registers against this update infrastructure, and then automatically the repositories are registered to the instance, and you're done. So after that, you shouldn't really touch any repository management. Everything is registered, and zipper up just works. If you have registration trouble, we need the support config. So that would then go, would be an L1 instance, and then would then first go to the Cloud Framework provider. Mind you, however, 95% of the cases that we see that have registration trouble are because of the network setup. So obviously there's nothing we can do about that. At present, we only support access to the update infrastructure via IP addresses that are handed out from the Cloud Framework provider. And there's a blog, we're changing this in June of 2020. We will allow instances to route traffic through a data center and that firewall and then back to the update infrastructure. So that path will be supported come early June. So when you want to launch an instance, of course, you have to find the image you want to use. And this is different per framework provider. So in AWS, you will find SLES for SAP OnDemand images in the AWS Marketplace. We are working with AWS to aggregate other images into the marketplace as well, but that's not completely finished. Then SUSE Linux Enterprise Server OnDemand can be found in the Quick Launcher, and all bring your own subscription and SUSE Linux Enterprise Server OnDemand images can also be found in AWS in the general catalog. So all BYOS, that means that includes SUSE Manager, which is bring your own subscription, is available. And shortly there will be a cloud application platform launcher in the general catalog, which is also BYOS. In Azure, all images are found in the marketplace, so this is pretty straightforward. And in Google, we also have all images in the marketplace. In addition, SLES and SLES for SAP on-demand images are also available in the Quick Launcher. And then there's the PINE tool that I already mentioned briefly, and PINE stands for Public Cloud Information Tracker. It's a command line tool that is backed by a REST API, so that's another service that the SUSE Public Cloud team runs. It can also be used from CloudFormation templates so that you can always find the latest image, and we have an example of that in a GitHub repository. This tool also provides a Python library, so you can write your own custom command line tool around it, or you can integrate it directly into your tooling. And it provides CSP provider appropriate information. So for AWS, it contains the AMI ID. For Azure, it contains the EARN, and for Google, it contains the image name, so that you can take the information that PINE provides and then launch instances from that information directly. And as I already mentioned, there's a demo about this in the public cloud roadmap session. So I recommend that you go and look at that. So once you have your image, then you can run your instances and you can proceed just if it were in your data center. So now let's talk about services, mobility, and data gravity. So services and mobility, and you can see here the arrow going to the right. And that basically means the more services you use, right, so which is on the left side of the graph, the less you will have mobility. So for example, if you do serverless implementation, if you have a serverless implementation of an application or parts of your application, it is going to be very hard to move from cloud service provider A to cloud service provider B. Very simply because, again, the APIs are different, the way things work are different, and you can't just throw the code at the wall and then make it stick on the opposite wall. It doesn't work. Okay, so this is one consideration, that you need to have a thought process about when you make decisions on how tightly you want to couple yourself to a given CSP. Then database services is another. There's potentially high effort and high cost if you want to move a database that has lots amount of data from one CSP to another. And in general, storage creates data gravity. Okay, so the more services you consume in your application, the less it is mobile and can be moved from one framework to the other. So now data gravity is a term that was formed that basically expresses the idea that your services or applications that depend on that data want to live close to your data, right? And so therefore the data creates a quote-unquote gravitational pull to locate your apps and services. So most of our data today is probably still in data centers, and this is why we then have, inventions like a truck that can roll up to your data center and you plug it in, and then the data is transferred to the storage array in the truck that drives to the cloud region. They plug it in there, and voila, your data is there. This actually makes it feasible to transfer very large amounts of data. But once the data is there, then you have data gravity, right? Well, you can get it out, of course, but that's not cheap. And so here's, an example. If you wanted to transfer 100 petabytes, which can be done with this truck in, a few days, if you were to do this over a T1 line, it would probably take, roughly estimated take 18,000 years. If you have a T3 line, you're at 619 years, and if you have OC3 connection, which runs at 155 megabits per second, then it still takes you 175 years. So this is clearly not feasible, which is why this truck exists, right? So if you have very large amounts of data and you want to transfer it to a public cloud provider, then that's the way to go and how to get it there in a reasonable amount of time. But you create data gravity, right? Now, the next thing I want to talk about is features that you should definitely consider, right? With the public cloud, what we have is elasticity, and that means elasticity also at the hard drive level, because hard drives are just another service within the public cloud framework, and they're attached and they're elastic. They can grow and they can shrink, and they can be attached as you see fit. So LVM is really dead, right? LVM was created to solve exactly this problem. In the data center, hard drive, you buy a hard drive these days, they're big, right? But obviously don't want to stick everything into the same partition, and so partitioning and LVM allows you to create many partitions and then set it up just so the way you like it. But when you, of course, run out of space, then you have to add another large hard drive, and you don't want to copy your data. And so having things in LVM volume groups, you can then stitch things together, and everything works nicely, and it provides this elasticity that you need at the storage layer. Well, in the public cloud, that comes built in. So from that perspective, you don't need LVM. So the problem that LVM is trying to solve in the data center on physical hardware doesn't really exist. That, however, comes also with limitations. So, for example, if you have data that you know is going to be more than 60 terabytes in AWS, 64 terabytes in Google or Azure, then you still want to come back to LVM, so long live LVM. But the important part here to consider is that you still want to separate your root partition, which our images have a certain size, and you should really live within that size for the root partition, and you want to put your data always on separate disks, right? The nice thing about this separate disk is, as I mentioned, they grow and they can shrink as you need, and you can attach as many as you want. So only if you think you're going to go above these data limits, then you want to consider LVM. But if you have an application that, say, writes 2 terabytes a year, then, well, in AWS, you can live with one disk for 8 years. And the nice thing about it as well is for the first year, you just allocate 2.5 terabytes to have a little safety, and then you only pay for that. And then the next year, you can grow that disk to 5 terabytes and so on, and you don't need to fiddle with LVM. So that's one of the nice features of having the elasticity in the public cloud. And again, remember, your data should always go on a separate storage disk. The default sizes of the instances that you're running, the root volume, is 10 gigabytes in AWS and Google and 30 gigabytes in Azure. That is more than enough than to allow you to install every package that SUSE brings as part of SUSE Linux Enterprise Server or SUSE Linux Enterprise Server for SAP applications or SUSE Manager and so on. So there should not really be a need for you to expand the root disk ever. Everything else should go in, onto separate disks. All right, and we're almost coming to the end, so now we'll talk really quickly about lift and shift or re-architecting. So lift and shift is basically the process of first understanding your data center application and then moving it verbatim to the public cloud. This is still very much appropriate. I know everybody hears about containers and Kubernetes, but not every application needs to run completely scalable. Many applications exist, they have basically no scaling requirements whatsoever. They get used by 100 or 200 people and they're just fine. And they don't need to scale to serve 1 million people. So there's no need for you to go tear this application apart to make it quote unquote scalable. And then still the same 200 people use it. So there's no gain for you, right? Also, many applications have slow feature implementation requirements, right? Even in-house applications, you may have written an application 10 years ago that is still running somewhere, and it still serves its needs. So there's no need to go tear it apart and turn it into microservices. Just move it to the public cloud if that's what you're interested in, right? You still benefit from cloud features, such as I mentioned, the separation of the storage for the application and the OS. The file system can scale, so you pay only for the storage that you need. Again, you may have applications that only run for 10 hours a day. You can take advantage of OnDemand and not have a system running for 24 hours. It is easier to right-size the system in the public cloud, and you may possibly improve network isolation because of the software-defined network infrastructure in the cloud service providers. And of course, you no longer have to deal with the hardware refresh cycles or hardware failures. So disk failures and all of those things become the cloud service providers' problems. You no longer have to fiddle with that. So lift and shift has a place, and there's still many advantages that you can take when you move things to the public cloud. Re-architecting, on the other hand, basically means you're tearing your application apart, you're modifying/rewriting an application to meet new needs. Maybe you do have an application that is, public and your customers have access to. Now, what happens when you run a sale? Maybe you need twice as many front-end servers. So these are applications that can definitely benefit from microservice architecture, Kubernetes, and being containerized, right? Or if you have an application that is really evolving fast and you need to turn features around. Again, a typical DevOps workflow with containers enables that, right? So applications like that can also take, relatively easily advantage of, database services or authentication services in the public cloud framework provider. Re-architecting, of course, can be expensive, and it will bring new bugs. And sometimes old bugs that were already fixed get re-implemented, and then you get to fix them again. So there are pros and cons to each direction. Each have validity, and there's not one general statement that one can make and say, many people say, oh, everything should be in containers, but that simply doesn't fit the reality. And so for QA, as again, the next time when we meet at some conference, come and look me up and we'll talk and drink a beer. And now a quick summary. Again, running your workloads in the public cloud is more than running on somebody else's computer. There are many services that you can take advantage of without tying yourself very closely to a given CSP, okay? The next part that you want to consider is bring your own subscription versus on-demand. you need to make that decision before you start instances. There is no switching back and forth. This is not a SUSE thing. This is a way that OnDemand versus BYOS tracked on the back end by the public cloud service provider. So if you start a POC with OnDemand because it's a POC and then you want to go in production and say, now I want it to be BYOS because now it's running 24/7, you have to stand up that application again on a BYOS instance. You can't go back and forth. The SUSE update infrastructure is region local, really fast to give you updates, and it's maintained to give you the best possible experience. It's set up in an HA environment. It is basically available all the time, and because it is region local, it is really fast. Services, mobility, and data gravity. So once you put your data in a certain place, it has so-called data gravity. The more services you consume from a given CSP, the tighter you couple yourself to that CSP, which is not necessarily a bad thing. It is just something you know to consider. And finally, again, the more cloud features you take advantage of, then you get tighter to the CSP. One of the features you definitely want to take advantage of is the elasticity of the storage. In general, you should not increase your root volumes over the default sizes that are provided, and your data should always be on additional disks. And consider the data limits, whether you may need or not need LVM, for example. And then lift and shift or re-architect. Consider the scaling needs of your applications. Consider the speed of feature development. Many applications simply do not need to scale to internet scale. And so there's not really a reason other than hype. And it's very expensive to follow the hype cycle. So be very considerate before you go and rip your applications apart and say everything has to be in a container. It really doesn't. Often what works in the DC, and if it's been running for years and you're happy with it and you want to move to the public cloud, it will work there just as well using a lift and shift approach. And with that, thank you very much. Please complete the session evaluation. Thanks for your time and enjoy the rest of SUSECON Digital.